detailed answer key for factoring polynomials. As we know, we always start off, what we've done each of these sections is start off by doing the multiplication and producing the polynomials. So let's look and see if we see patterns that we can recognize that can help us. So this is two binomials, two terms times two terms, and we know that we're always going to utilize, well, my pen doesn't work already, not a good sign. We're going to use the distributive property. We're going to distribute this x into the other binomial, and then we're going to distribute the 5 into the other binomial. We call that FOIL, first, outer, inner, lasts. And we'll notice that our outer and inner, 99% of the time, we're going to be able to add those. And we will produce a polynomial that will have this format: ax squared plus bx plus c. That is a quadratic expression. Quad because it's x to the second. So if we do x times x, we do first times first, that's our f, you get x squared. If you multiply your outside, notice the outside two terms, that's your next distribution, you get 3x. And then your inside, those are your inside two, you get 5x. And then your lasts, because those are the last of each of the binomials, you get 15. And as mentioned, you can add your outside and inside, and your final answer is going to be x squared plus 8x plus 15. And that's what we're going to do with each of these binomials. First times first is n squared. First, the outside gives you negative n, inside gives you negative 2n, and the last give you positive 2, n squared minus 3n plus 2. V squared plus 7v plus 3v plus 21, v squared plus 10v plus 21. And we should be able to do these that fast. You get n squared minus 8n minus n plus 8 gives me n squared minus 9n plus 8. N squared minus 6n plus 36. N squared minus 12n plus 36. Some of you notice something special about that you may see that problem start off like that. This is a binomial squared. We have a binomial that is being squared. And there's a shortcut, and that shortcut is a squared plus 2ab plus b squared, where this is my a value, this is my b value. So a would be n squared plus 2 times n times negative 6 plus, oh, that should be b squared, sorry, plus b, which is negative 6 squared. So you get n squared, 2 times n times negative 6 is negative 12n, negative 6 quantity squared is plus 36. Did we get the same answer? Yep. And that's a shortcut, but you can use FOIL. FOIL is a very efficient way. So let's move on to 6. You get the first is x squared plus 4x minus 8x minus 32, x squared minus 4x plus, minus 32. And now we're multiplying. If you notice these first problems, these first group of problems, the signs were the same. They were both positive, both negative, both positive. Number 4 was both negative, 5 is both negative. So we did that on purpose. And now we move on to 6 where our signs are different. We have a positive and a negative. How does that affect these final answers? What are those final answers? Are there any characteristics that are consistent every time we multiply signs are the same or signs are different? So number 7, when we multiply, we get our first is a squared plus 6a minus 6 gives us a squared plus 5a minus 6. We get x squared minus 6x plus 5x minus 30. We get the minus 30 because we're multiplying the lasts. Remember, these are always going to be products. This is always going to be the sum of those two. So x squared minus x minus 30. These are products. These are products. This is produced by multiplying. And this middle term is our outside plus our inside. This is our outside. This is our inside. So b squared minus 7b plus 3b minus 21. B squared minus 4b minus 21. N squared plus 3n minus 6n minus 18. N squared minus 3n minus 18. Ooh, here's an interesting one. So this is conjugates. They're opposite. So we can still do it. Firsts gives us 36v squared. Outside gives us negative 12v. Inside gives us positive 12v. And last is negative 4. We notice this time with our outside and inside, they end up being opposites. So my final answer is 36v squared minus 4. And when we have conjugates, you'll notice that the inside and outside end up being opposite of each other because these binomials are almost exact, but they have different signs. So one is 6v plus 2, one is 6v minus 2. And because they are nearly identical but opposite signs, those outside and insides will end up being opposite of each other. So we'll be just left with the first and the last. And you'll notice that the first are identical, 6v times 6v. And the last is 2 times negative 2, which gives us a negative 4. And this produces the difference of squares. Notice we are subtracting two perfect squares. Those are both perfect squares. So conjugates will always produce the difference of squares. So we have conjugates here. So I know my outside and my inside are going to be opposite of each other. Positive 10v and negative 10v. So I don't even have to do that part. I should know with conjugates, all I need to do is multiply the firsts, which gives me 4v squared, and I multiply my lasts, which is negative 25, and that should be my answer. That's an observation one. I observe, I notice that they are opposite of each other, that they are conjugates. So I'm going to make that 49n squared minus 49. I got that by multiplying the firsts and the lasts, because my inside and outside will cancel because they will be opposite. This is not conjugate. This is called a binomial square. So again, I can either write it out and do the long FOIL, which gives me firsts, outer, inner, and lasts. And I'd notice in all binomial squares, my outside and inside will be identical, not opposite, they're going to be identical. So there's two of those. So I'm just doubling that value. Hence why that template is a squared plus 2ab plus b squared. We have 2 of a times b. 2, this is my a, this is my b. A times b. So if I multiply, because look, there it is, there's my a and b, here's my a and b, and I have two sets of those. That's why it's 2ab. But if you see it, awesome. If you don't, so we can do 3n squared, which is 3n quantity squared, which is 9n squared. We know that we're going to have 2ab plus 2 times a times b, which gives us 2 times 3n is 6n, times negative 7 is negative 42n, and then plus b squared, which gives us positive 49. So that's a nice, easy way of simplifying it. But if you want, please, by all means, feel free to write 3n minus 7 times 3n minus 7 and do the foiling. You will still end up with the same exact answer. I'm going to do the shortcut. 64v squared. 8v times 3 is 24. Double it is 48v. And then I'm going to square my last, which is 9. Now we are going to factor. So now we're going to reverse the process. We're starting with this, and then we have to produce those. Much like with these ones. We're going to start with this, and then we have to produce the two binomials. So how do we do that? Well, we have this trick or this process called A times C. So I'm going to look. Well, first of all, I have, is it in standard form? M squared, M, my constant. Yes, it's in standard form. Second thing, is there a common factor? Is there a variable in all three of these? No, a common variable. Is there a common number or factor, coefficient that goes into all those three? No. So my next one is SC, which stands for special cases. And the first special case is binomial square. And binomial square has 4 characteristics. First one, 3 terms. Does this have 3 terms? Yes, it does. Next one is the third term positive? And yes, it is. Okay. The third criteria is the first and third perfect squares? This is a perfect square, but this is not a perfect square. No number times itself equals 24. So I know it's not a binomial square. And then there was the fourth criteria. If we had passed that third criteria, the fourth criteria, does the absolute value of the middle equal 2 times the square root of the first times the square root of the last? And if it does, then we know it's a binomial square, and we would produce something like that. But it's not. The next special case is difference of squares. And there are only 3 criteria for difference of squares. First one is 2 terms. This doesn't have 2 terms. This has 3 terms. So we know that it's not difference of squares. But the other 2 criteria is 2 terms, subtraction, and both perfect squares. But we already know that it's not because it doesn't have 2 terms. This has 3 terms. So if it doesn't, then it's not a special case, and I need to move on to criteria or factor technique 4, which is A times C. And we're going to do that method here. So remember that these quadratics are written in this form. The coefficient of x is my a value. The coefficient of x squared is my a value. Coefficient of x is my b value, and the constant is going to be my c value. So when I say a times c, my a is 1 and my c is 24. So I'm going to multiply 1 times 24, and I get 24. And the next thing I'm going to do is I'm going to write factors of 24. I'm always going to start with 1 and 24. Then I'm going to go numerically. So I'm going to test 2. Does 2 go into 24? Yes. 2 and 12. What comes after 2? 3. Okay. Does 3 go into 24? Yes. 3 and 8. What comes after 3? 4. Does 4 go into 24? Yes. 4 and 6. What comes after 4? 5. Does 5 go into 24? No, so not a factor. 6, oh, I already have 6 and through 24. I've already got those factor pairs. So here are all my factor pairs. Now, the next thing after I get my factor pairs, I have to figure out my signs. So I'm always going to look at this, the sign of the constant first. If that's a positive, remember this is made by a product of two numbers, so we're multiplying two numbers. The only way you can get a positive sign by multiplying two numbers is either multiplying a positive and a positive or a negative and a negative. That's the only way that you can get a positive through a product. So these factor pairs, these outsides and insides, that's what these factor pairs represent, is my outside and inside. They're either both positive or both negative. And if they're both positive, when I add them, that's going to make a bigger positive when I add them to get my middle. Because remember, this is O plus I. It's a sum of two things. So if I have positive, positive, I'm adding, it's going to make a bigger positive. If I had negative, negative, it would make a bigger negative. But since my middle sign is positive, I know this tells me two things. Ready? This, if this is positive, the signs are the same. And then I look here and I see that that's a positive. That tells me that both are positive. So I go to my factor pairs and I make them both positive. Remember what these numbers represent is my outside and inside. So I'm going to add them together. 25, that's 14, that's 11, and that's 10. I'm looking to see which one of these sums is equal to my middle, and that would be 4 and 6. This equals my middle value because it's a sum. So this is my outside and inside. So I'm going to rewrite this trinomial, and remember we're moving backwards, so I'm going to write it as m squared plus 4m plus 6m plus 24. 4m plus 6m gave me my 10m. And this is my outside and inside from foiling. Remember, we're just reversing the foiling process. So now I have four terms, and we're going to utilize what we call factor by grouping. We're going to factor by grouping, and we're going to look for the GCF of both of these pairs. So looking at the first pairing, what's the common factor? They both have an m. So I can factor out an m from both of those. Factoring, we have to remember how to factor. We saw this earlier. So if I have m squared and 4m, prime factorization of m squared is m times m. Prime factorization of 4m is 2 times 2 times m. What do they have in common? They have an m in common. So that's going to be my GCF is going to equal m. That's how I got this value right here. That's my GCF. And if I take it out, if I take an m out of m squared, what is left? What's left here? An m. That's where I got this value from. And if I factor an m from 4m, notice what I have left. 2 times 2, which is 4. So that's how I got those values. That's how that happened. I found the GCF of that pair. And I'm going to do the same thing to this set of numbers. So 6m and 24, we should get so good that we can see that the GCF is 6, and that gives me m plus 4. Okay, factoring is a form of division, and we have to, what we're doing is just dividing. So we know that we did it right when these two parentheses are the same. They must be the same. And we see that both of them are multiplying another piece. So if we pull that out, if we factor that out in m plus 4, what's left? If we cover it up, if we cover both of those up, what is left? What do I have left if I factor both of those? If I pull both of those out, what am I left with? Anybody see that? You see what we're left with? We're left with m plus 6. And that's going to be my other binomial. Kind of cool, right? Hopefully that's cool. Hopefully you see the logic of that. And that's what A times C is. We turned addition, subtraction, of 3 terms into the product of 2 terms. We had m squared and we had m, and notice the beauty of this problem now is we have the same variable, just m to the first. All right, let's move on to the next one now. We're going to move a little bit faster. So factors, we're going to do a times c. A is 1, c is 80. 1 times 80 is 80. Factors of 80 are 1 and 80, 2 and 40, 3 no, 4 and 20, 5 yes, 5 and 16? Maybe, yeah, 16, I think it's 16. Yeah, 16. 6 no, 7 no, 8 and 10. And that looks pretty good. Signs are, since this is positive, I know that means the signs are the same. And then I look here and both are positive. So both are positive. I'm going to go here with my factor pairs. And notice my factor pairs are in numerical order. 1, 2, 4, 5, 8, 10, 16, 20, 40. And the smaller is on the left side and the larger number is on the right side. That doesn't really make, that's not super important here, but when those signs are different, it will make a huge difference. So we get 81, we get 42, we get 24, we get 21, and we get 18. Notice my middle is 18. I'm looking for that number from these sets. So this one's equal to 18, so I know that this is my outside and inside. So I'm going to rewrite this trinomial into 4 terms. 8x plus 10x plus 80. Where did I get this 8 and 10? I got them from here. Those numbers move over to this side. And now I'm going to group. I'm going to group the first 2 and I'm going to group the last 2. I'm going to look at the first 2, x squared and 8x. I can factor out an x. That leaves me with x plus 8. I look at my second group, 10x and 80. I can factor out a 10. You must have a sign here. If there's no sign here, you're telling me if you just have this, that means multiplication. So we must have a sign there. I'm factoring a positive 10, so I'm going to write positive 10. If we factor out a 10 from 10x and 80, we get x plus 8. I know I did it correctly because this and this are the same. They must be the same. So I'm going to factor that out. And what's left is x plus 10. X plus 10. A times c. We have 1 times 25 equals 25. Factors of 25 are 1 and 25. 2 no, 3 no, 4 no, 5 and 5. Signs are the same, but this time both are negative. So negative, 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 negative. This gives me negative 26. This gives me negative 10. Which one equals my middle? Negative 10 is my middle. So I'm going to choose negative 5 and negative 5. I get x squared minus 5x minus 5x plus 25. I'm going to factor the first. I'm going to factor out an x. I get x minus 5. Something interesting happened here in my second group. So my second group here, notice my first term is negative. This is a negative 5x. If we have a negative as my first term, I must factor out a negative. So I got to factor out a negative 5. If I factor out a negative 5 from negative 5x, that leaves me with x. If I factor out a negative 5 from 25, remember it's dividing, that leaves me with negative 5. And we can check, what's negative 5 times x? Negative 5x. What's negative 5 times negative 5? Positive 25. So that is correct. It's a nice check. These are the same, so I'm going to factor out an x minus 5, and you're left with x minus 5. You can leave it like that, or a high school student would write it like that. What do we notice? Hey, that was a binomial square. So remember how we went through that checklist of things. Do you remember? that list. Let me see if we have that list. There. No, that's not the list. Here's the list. Here we go. So we're always checking standard form, common factor, and then special cases. And we check these 4 criteria. A times C is going to work, whether you notice the special case or not. So in this problem, we had x squared minus 10x plus 25. X squared minus 10x plus 25. So if we checked for a binomial square, we had those 4 criteria. First criteria was 3 terms. Does this have 3 terms? Yep, it has 3 terms. 1, 2, 3 terms. The next criteria was third term was positive. Yep, their third term was positive. That worked, yes. So that's a check also. The next criteria was first and third are perfect squares. Is this a perfect square? Yep. Is that a perfect square? Yep, 5 times 5, x times x. So that's a yes. And then the fourth one, which tends to be the most challenging one to test for, is the absolute value of your middle. So here's my middle term. The absolute value of that would be 10x. Does that equal 2 times the square root of the first? Square root of x squared is x times the square root of the last. Square root of 25 is 5. Does 10x equal 2 times x times 5? 2 times x times 5 is 10x. And yes, it does. So we know that this is a binomial square. So I know that it's a binomial square. The way you find, you take the square root of your first, the square root of your last, and then you take the sign of there. So that sign comes down. So this is your answer. The quantity of x minus 5 squared. Was that what we got over here? Oh yes, the quantity of x minus 5 squared. Yep. So if you want to see that, that is an observational one. If you don't see it initially, and the thing that was the real telltales was perfect squares. That should make me test for a binomial square. I should recognize perfect squares for the remainder of my life. You will always notice, and that would give you the time to say, oh, I'm going to check to see if that's a binomial square. You can always do A times C. It'll always still work. All right, so that's not a perfect square, so I'm not going to check for binomial square. I'm just going to move along with A times C. A is 1, C is 70, factors of 70, 1 and 70, 2 and 35, 3, no, 4, no, 4, no, 5, yes, 5 and 14, 6, no, 7, yes, 7 and 10. So signs are the same. Since this is a positive, they need to be the same. And then we look here and they're both negative. Negative, 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 negative. Negative 71, negative 37, negative 19, negative 17. I have negative 37, so I know that my inside and outside are going to be negative 2 and negative 35. So I'm going to rewrite this. R squared minus 2r minus 35r plus 70. And now I'm going to pair them. Factor by grouping. I have a common factor of r, and I have a negative as my first term, so I have to factor out a negative. And I'm going to say negative 7. Let's see. So 7, that gives me 5r, and that's minus 10. Okay, because I know 7 goes into 35 and 70. But did I do it correctly? I did not do it correctly because these are not the same. Not the same. So I know that I didn't pull out the greatest common factor. I didn't factor enough. So I got to look for a number bigger than 7. 14 goes into both of these. 35 also goes into both of those. I didn't know that. That one was a hard one. But now I know I did it correctly because these two parentheses are the same. They have to be the same. So this was a real good one, a real tricky one. So I pull out the r minus 2 and it leaves me with r minus 35. Number 20 will be interesting to see how many people get that one correct. 21, 18 is not a perfect square. Yes, 9 plus 9 equals 18, but remember perfect squares are multiplied to make that number. No number times itself equals 18. So a times c, 1 times 18 equals 18. Factors of 18, 1 and 18, 2 and 9, 3 and 6, 4 no, 5 no. We're already back around the horn. If it's a positive, we know the signs are the same. We look here and both are negative. Negative, 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 negative. Negative 19, negative 11, negative 9. My middle term is negative 11, so I know I'm going to use that as my outside and inside. So b squared minus 2b minus 9b plus 18. Factor a b out, I get b minus 2. First term is negative, so I have to factor out a negative 9, and I get b minus 2, b minus 2, b minus 9. And I can always check. I haven't even talked about this. Once we get our solution, you can FOIL it back out and make sure you get that as your product of those two binomials. That's your check that you can always do, no matter what. 40 is not a perfect square, so I'm not checking for a special case. Notice both special cases deal with perfect squares as your first and last. So that's really a quick think about. A times C, A is 1, C is 40, gives you 40, 1 and 40, 2 and 20, 3 no, 4 and 10, 5 and 8. Signs are the same, and they're both positive. Positive, 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 positive. 41, 22, 14, 13. Okay, that's my middle, 14, so I'm going to use 4 and 10. P squared plus 4p plus 10p plus 40. I'm going to factor out a p. I get p plus 4. I'm going to factor out a 10, and I get p plus 4. And my answer is p plus 4 times the quantity p plus 10. That's how fast you should be able to do these. So 6 is not a perfect square. I'm going to still do a times c. A is 1. C is negative 6 this time. So we're still finding factors of this, 1 and 6, 2 and 3. But this time, that's a negative. And remember, this is made by a product. You're multiplying two numbers. The only way you can get a negative by multiplying two numbers is if one is positive, one is negative, or one is negative, one is positive. So we know from that my signs this time are going to be different. And then we look here, and that sign's going to tell me that the bigger of my two outside and insides is going to be negative. So this is my outside and inside. Which one's bigger, 1 or 6? 6 is bigger, so that's going to get that sign. So this gets negative, this gets positive, because remember, the signs are different. Okay? So we look at these two numbers. 2 and 3, which one's bigger? 3 is bigger, so it's going to get this sign. This sign will always go to the bigger of the two. That means this must be positive. Positive 1 and negative 6 makes negative 5. Positive 2 and negative 3 makes negative 1. Which one's equal to my middle is negative 1. There's negative 1. So my outside and inside, is positive 2 and negative 3. So I'm going to rewrite this k squared plus 2k minus 3k minus 6. We're still going to pair them up. Factor out a k. You get k plus 2. First term is negative, so I'm going to factor out a negative 3. And I get k plus 2. K plus 2, k minus 3. And there's no reason for you to get the wrong answer, because we should take this and check it. Multiply it back out real quick to make sure that you get your starting trinomial. K squared minus 3k plus 2k minus 6. Outside and inside, negative 3k, positive 2k produce a negative k. And that's what we got, k squared minus k minus 6. So no reason for you to give me a wrong answer, because we can check our answers. All right, 48, not a perfect square. We're going to do a times c. 1 times negative 48 is negative 48. Factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5, no, 6 and 8. Signs are different. If this is negative, the signs are different. And we look here, and the bigger of the two is positive. 48 is bigger than 1, so the 48 gets the positive, the 1 gets a negative. Positive, negative. So all of the bigger will be on this side, all the smaller will be on this column. So I know that all of these numbers on the right, because I placed them small to big, will be on the right. So I can just go down. And remember, what's negative 1 times 48? Negative 48. What's negative 2 times 24? Negative 48. What's negative 3 times 16? Negative 48. Negative 4 times 12? Negative 48. Negative 6 times 8? Negative 48. So these are always going to be the product produces this after I put my signs in. And then the sum of these will always equal, we're testing, will be my middle. So I get 47, I get 22, I get 13, I get 8, and I get 2. And 2 is my middle, so I know that negative 6 and 8 end up being my outside and inside. So v squared minus 6v plus 8v minus 48. Pair them up, factor out a v, pair them up, factor out an 8, and I get v minus 6, v plus 8. Voila! Really, really good technique. So sound, especially later on when a is going to be greater than 1. You're going to love a times c. 72, not a perfect square. A is 1, c is negative 72. Factors of 72, 1 and 72, 2 and 36, 3 and 14, no, 24. Almost made a mistake there. 4, yes, 4 and 18, 5, no, 6, yes, 6 and 12, 7, no, 8, yes, 8 and 9. So I can do factors of big numbers, even 72, in my head. That's because I know my times tables, because I know my number sense. You only get that by practicing. And that is something that is extremely important. So, since this is negative, we know the signs are different. And we look here, and the bigger is going to be positive. So remember, all my biggers are on the right side. So all of these are going to get positives, and the signs are different. So if the right side is positive, the left side has to be negative. That gives me 71, 34, that gives me 21, 14, 6, and 1. My middle is equal to 1, So I know that my outside and inside is -8 and +9. -8 and +9. I'm going to factor out a k. I get k minus 8. I'm going to factor out a 9, and I get k minus 8. K minus 8, k plus 9. I know what you're saying. Mr. Mack, every single time it ends up being -8 and 9. Or 6, -6 and +8. -6 and +8. Yes, that works in these very rudimentary, very beginner thing. When your coefficient, or when your a is 1, you will notice that pattern. But since we haven't done it where a isn't 1, you'll then notice that it won't be these two numbers, that they'll be a little bit different. But when your coefficient is 1, yes, these are what the numbers inside your binomials. Only when a is 1. That only works when a is 1, as another shortcut, shall we say. 20, not a perfect square. A times c, 1 times -20 is -20. 1 and 20, 2 and 10, 4 and 5. Signs are different. Bigger is positive. You get 19, you get 8, you get 1. 19, love that. N squared minus n plus 20 and minus 20. Now, if you want to write minus 1n in this place, this is the only time where I'm okay with you writing a -1 or a 1 as a coefficient. Typically, we don't write 1 as coefficients, but I'm okay because we're going to see this actually helps us. So if we factor in n from here, you're left with n minus 1. It's a little bit easier to see when you take the n why you're left with a -1. Some students struggle with that. You'll see it here. You're going to factor out a +20, and you're left with n minus 1. If we factor a 20 from -20, oftentimes students just write that. But if we multiplied this back out, did we get this? No, you just got the 20n. So you need a placeholder for that -20 when we factor it out. That makes sense. Those are the same, n minus 1, n plus 20. That's a good one. There will be people, oh my goodness, look at this. Red flag, ding, 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 ding. 2 terms. That should show me a red flag. I should be testing for difference of squares. Does it have 2 terms? Yes. Is it subtraction? Yes. Are both perfect squares? Yes. So I know that this is going to produce conjugates. I know that they're going to be identical, but the signs are going to be different. The way you do it, square root of your first is going to be your first, square root of your last is going to be your last, and then we're going to have +1 and -1. That is the easiest way to do it. Now, let's say you didn't remember difference of squares. Let's say that you're still going to use a times c. Well, remember that this doesn't have a middle term. It's missing its x value. It's missing it because the coefficient of x is going to be 0. So we can still do a times c. A is 1, c is -1. Factors of 1 are 1 and 1. Signs are different. And the bigger is positive. Well, Mr. Mack, 1 and 1 are the same. No one's bigger. Okay, well, we're going to have to associate. We're going to have to just put the positive sign with one of them, and we know our signs are different. Notice this still equals my middle. So I'm going to take these two values, and I'm going to rewrite it just like I did on every a times c. I'm going to group them up. What's the common factor? There's an x in both of those. Ooh, this is a fun one. What's the common factor? They both have a 1. Woo! Mr. Mack, you've always told me not to factor out a 1. You're right, but we need to factor in order to get that parentheses. So if we factor out a 1, do we still have the same? Yes. So we pull that out and we get conjugates. So that's a very, very technical, very unique one. Practice that so you're familiar with the rules and the steps through it. It's kind of like chess. You know, you have openings, and it's through patterns that you, oh, I remember this is how I do my opening. I go through these set of moves. I recognize something. So that's the same ideology. Not a perfect square, so we're going to do a times c. 1 times negative 14 gives me negative 14. 1 and 14, 2 and 7, 3, 4, 5, 6. Nope. Signs are different. Bigger is positive. Negatives on this side. I get 13. I get 5. This is my middle. I'm going to use these two values. X squared minus 2x plus 7x minus 14. Factor out an x. Factor out a 7. And I get x minus 2, x plus 7. By this time, you should be really proficient at a times c. 48, not a perfect square. A times c, 1 times negative 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5, no, 6, 8. Signs are different, and the bigger is negative. So I'm going to throw negatives down on this right side because all of these numbers on this side are going to be bigger than all the numbers on this side. The technique that I've used provides you that luxury and that simplicity, that efficiency. Signs have to be different, so one side is positive, one side is negative. That gives me negative 47, negative 22, negative 13, negative 8, negative 2. My middle is negative 2, so I'm going to use positive 6 and negative 8. P squared plus 6p minus 8p minus 48. Factor out a p. I get p plus 6. First term is negative, so I have to factor out a negative 8. P plus 6. I did it correctly. P plus 6, P minus 8. We're getting real good at this. Factors, not a perfect square. 20 is not a perfect square. And we get A times C we're going to test out. 1 times negative 20 is negative 20. 1 and 20, 2 and 10, 4 and 5. Signs are different. Bigger is going to be positive. I get 19, I get 8, and I get 1. Uh-oh. Notice, none of these equaled my middle. My middle was positive 5. I had 19, 8, and 1. None of those were equal to my middle. So that means A times C method, I wasn't able to utilize it. It didn't factor my trinomial. Much like when I tested for special cases or a common factor. When it didn't work, I just moved down that hierarchy. So we're going to say not factorable. So we can't factor this at the moment. I'm going to teach you another technique when you hit this roadblock. So there's still other ways of factoring trinomials. A times C in this instance doesn't work. So we just say not factorable, okay, or unfactorable, either way. Let's move on to 31. 28 is not a perfect square. A times C, 1 times negative 28, negative 28, 1 and 28, 2 and 14, 3, no, 4 and 9? No, not 4 and 9, 4 and 7. Mr. Mac, whew. Signs are different. When this is a negative, we know our signs are different. And then we look here, and the bigger is going to get the negative. Negative, 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 positive, 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 negative 27, negative 12, negative 3. My middle is negative 12, so I'm going to use these two. And I have b squared plus 2b minus 14b minus 28. Factor out a b, I get b plus 2. First term is negative, so I'm going to factor out a negative 14. b plus 2. b plus 2, b minus 14. Again, it's worth your effort to check your answer every single time before you hand in your test. There's going to be no reason for you to hand me back a test that doesn't have 100, because you've checked all of your answers before you handed it in to me. You will know exactly what score you got on your assessment as you hand it in. 2 is not a perfect square, so we're going to do a times c. 1 times negative 2 is negative 2. Factors of 2 are 1 and 2. Signs are different. Bigger is negative, so negative, positive, negative 1. That equals my middle, so I'll use those two. X squared plus 1x minus 2x minus 2. Factor out an x, you get x plus 1. Factor out a negative 2, and you get x plus 1. X plus 1, x minus 2. A little bit of a tricky one because we're factoring out some interesting numbers. And that's it. That's your homework. All right, hopefully that all worked out. Come and see me. That's a lot of work, but well worth it. Good luck on the assessment.